Next is the trip demand modelings. So in this trip demand modeling, the whatever the trip demand modeling, so that will mainly the trip demand modeling, so that will mainly aims to establish to a spatial distribution of the travel by means of the appropriate system of the zones. So the zone modeling of the whatever the demands, so thus it implies the procedure of the predicting the whole and the whatever the traveled decision of the people, so that would like to made and given in the generalized travel cost of the each alternating routes are there. For this, each whatever the cost for all these alternative routes, so the base decisions, so that includes the travel length and travel cost and the choice of this route and the choices of the destination. So from one origin to this destinations, so what are the two choices of the routes, so alternative routes, so that all the whatever this alternate routes are there. So although the various modelings, so there will be various modelings will be placed. So this various models, so in this various models, the approaches of the different approaches which is been adopted, so will be given in the discussions. So in this discussion, only a classical or the transportation models will be discussed, and in this various models where the particular any suitable which has been which is very optimum usage of this travel demand more is been met, so that model will be taken. So in this classical way, the in the various models, the where the probably the model probability that has been taken in the four stages of the models, so that will be given in this various stages. So that four various stages, so that will be given in this flow diagram. So first the databases will be collected, so that is been a network data and the zones and the basic year data and the future planning data. So these three which has been taken databases will be taken into consideration. Next it has been concentrated on the what are the trips which is being generated in the various points, and through all those points from all those zones, so whether the trip distributions, so what is the amount of the trip distributions which is exhibits, that will be checked. So with this trip generation and the trip distributions, so the models will be splitted for the assignment of this various models approaches which has been adopted, so that will be taken into consideration. So in this model splits, the trip assignment will be taken into consideration. Later, the whatever the output of the links, so that inflows the trip matrix, inflow of the trip matrix, and the which has been generated, the attracted and by the zone, each zone, the next step which has been allocation of these trips from the each zones to that of the various other destination zones in the study area using this trip distributions model. So the output of this above model is a trip matrix which has been generated, which has been denote the trip of from the each zone in the very other zones. In this succeeding this trip, the trips which has been allocated to the different modes of the transportations, this mode that has been based on the model which is being used for the model split matrix. This essential slicing the trip matrix for the various modes of the generated to the mode specific trip matrix. Finally, whatever the each trip matrix that has been assigned to the root that of the network a particular mode using the trip assignment model, the steps which will be going to the loading on each link of the network, the model would be viewed by the answering the series of the questions, so such as how many trips which has been generated in any particular routes, so where there is a going and on what mode they are going, and finally which route they are adopting. So these are the crucial questions which is being asked in this, the whatever the current approach that is been to model using this decision using this discrete choices, the various theories which allows the lower level of the choices that has been made by the people, so conditioning of the lower choices, conditioning of the higher choices. For example, if you take a route, choices is a condition which is been on the modal choices, so there is a hierarchical choices of the which has been trips, so that is the data trip frequencies and the destination choices, mode choice, route choice, and supply which has been made in the network performance. So in this all this the highest level to the level to the lowest level, that trip which has been originally from the zone which has been calculated based on the data and aggregate the cost term based on the cost travel, so to the origin to the destination, the probability whatever the trips which has been going from the zone I to zone J that has been computed subsequently, the trips from the Tij to from the zone I, the trips from the Tij from the zone I to zone J, that from all the modes, all the routes which has been computed, and the next mode of the choice and the model which has been computed, the probability of choosing which has been made from the different mode M, the based on the travel cost you can say that as that of the CJM. So from the zone I to from a zone I to J. So this from the mode different mode M which has been determined similarly, the route choice which has been gives the trip Tij from the zone I to zone J in the mode M through more different mode that can be computed, that can be finally travel demand which has been loaded to the supply model. So the whatever the stated earlier will be produced in the form of the performance level. The purpose of the network is usually measured in the travel time, so the which that could be converted to the travel cost. So time is converted to travel cost. So whatever the all this the practically and practiced ideal and ideological and the ideal method, so one could feed this in the back in the higher level to achieve the equilibrium between the supply and the demand.